Welcome everybody. In today's class we will start by learning and understanding the concept of measure of central tendency. Now if you know this concept, you have already achieved 80% of the knowledge of statistics. So it is critical that we understand what really constitutes the measure of central tendency. So I'm going to list down the parameters or the requirements to understand measure of central tendency. Now we need to know about arithmetic mean. We need to know about the weighted mean. We need to know about the median. We need to know about the percentile. Now, having known all these things, we also need to know. So all of these things will constitute the measure of central tendency. Now, before I could go to the next heading, I have already explained to you what is the arithmetic mean and also about the weighted mean, and we have also done some problems with the median. So in this class what I'm going to focus is I'm going to actually give illustrations of the arithmetic mean, the weighted mean, and then I will also teach how to exactly obtain the different types of median, and then we will move on to percentile. Now I have started with D. What I really meant is I would also continue on teaching you what is called as dispersion. So that is done after I have completed the left side, which is the measure of central tendency. Now if you were to review my previous lesson, I have already completed the arithmetic mean in 2 illustrations. So for that I would like to request you all to go and check those lessons, which link I'm going to attach here. So those lessons are critical. So having given you that information, let me start on. Okay, if someone were to ask you what is arithmetic mean, the definition is as follows. I will give you that statement and that would help you in understanding the arithmetic mean. So it is a single number that represents the entire data. This is the basic definition of arithmetic mean, and as I mentioned to you, I have already done detailed videos of arithmetic mean and how exactly to find them, as well as arithmetic mean of grouped data. Now this is the key understanding. It is a single number that represents the entire data. So that is why we are interested in arithmetic mean. So for example, just to perform the review, you take a class. Now a class has 100 students and you want to find out the score of the class in math test. Now it is going to be a difficult task to get the scores of all the 100 students and then study them using visual comparison. That's not going to be easy. But what we are going to do is we are going to take what is called as a sample. Now sample is nothing but a set of data to represent the population. Now whenever I use the word population, in this case the population is the class. So 100 is the population quantity. Now when I say set, when you say set is nothing but well defined collection of objects, right? So sample is nothing but we selectively pick up elements from the population. So you have a population, this is the class size, say 100 students. From 100 students I'm going to pick up the following samples. Now, of course, to get the sample, there are different techniques, but we don't want to go into that in this class. Later on, I will explain to you the different levels by which sampling can be applied. So in this case, we are just taking a sample from the population. So this is going to be my sample data: 20, 22, 24, 26, 28, 30. Now, if you want to find out the class average, as I mentioned to you, we have another name for arithmetic mean. We also call it as class average. And why are we looking into class average? Because that one will give you an understanding of the entire class's capacity in solving math questions. So, having mentioned to you that, how are we going to get the average? This is the formula. X bar is equal to sigma x divided by n. When you talk about sigma x, you have to add up all these quantities. And you have to divide by the number of sample size. So when I say number, I mean this quantity: 1, 2, 3, 4, 5, 6. 6. So you divide this entire sum by 6, and that is going to give you the class average. So this is called the arithmetic mean. Now there are two important distinctions you have to know. Now this is called as the sample, right? This is the sample. It is represented as x bar. Now if you want to take the mean of the entire class, the mean of the class, then you are actually trying to obtain the mean of the population. So in that case, you have to use the term mu, not x bar. So mu is equal to, again the same formula can be used. In this case, you will have to sum up x1, x2 up unto x100. So when I say x1, x2, x3, I mean x1 being the mark of the first student, right? So in this case, I'm going to say x1, comma x2, comma x3, etc., xn are marks in math test, right? So that is the basic understanding that you need to know. So having given you that understanding and that illustration for arithmetic mean, let me go and also give you an illustration for obtaining the weighted arithmetic mean, right? So that's going to be my next illustration. So I hope you got this illustration well and good. So let me move on. This is how we calculated the weighted mean. Now, when do we have this issue, or when exactly we would come across this case? I'm going to give you this beautiful illustration. Now, there is a survey company that is conducting the number of mobile. When I say mobile, it means mobile phones, okay, that each household has. So when I say household, I'm talking about families, right? Number of mobile phones that each families have with them. And this particular company which is performing the survey is performing this exercise across 1000 families, right? So this is the data that they have got. This is mobile phones and families. Now what they have found is that 73 families have one mobile phone and 378 families have got two mobile phones. 459 families have got three mobile phones and 90 families have got four mobile phones. Now this is the data that they have collected. Now the most important question is, on an average, how many mobile phones does a family hold? So you need to come out with a number. That number should represent this entire data that we have here, right? So the question, this is the research question. On an average, how many mobile phones does a family hold, right? So we are actually finding a very important research question, the answer to this research question. So how are we going to do that? Now what we need to do is we need to use this formula. So x bar is equal to sigma. Now these are taken to be as the weights and these are taken to be as x's. So we would have to write the formula like this: wi times xi. I is equal to 1, 2, 3, 4. So that would be divided by sigma I is equal to 1 to 4 wi. So that is the all important formula that you need to know. So having got that, let me calculate sigma wi times xi. That would mean I need to take the weight. In this case the weight is going to be 73 multiplied by a family positive 378 times 2 positive 459 times 3 positive 90 times 4. Okay, that's the weight. So this will give you 2566. Now what you got to do is you have to find the weight. I is equal to 1 to 4 of wi. So as I mentioned to you, this is the weight. So 73 plus 378 plus 459 plus 90. This is the weight that we have summed up, and that has accumulated to 1000. Divide by 1000 and you get the value of 2.566. So what is the conclusion? You got to state the conclusion. So on average, you can state it like that. Let me give the conclusion like this. On an average, each family has 2.566 mobile phones with them. Okay, so that is how we calculate the weighted mean. Now next comes the median. Now I understand that we have done questions related to median, but let this act as a review class also. Now these are the characteristics of the median. Now this is the middle value in an ordered array of numbers. Now we can apply median to ordinal data, interval data, and to ratio data. It is imperative to understand we cannot apply mean to ordinal data. We can only apply mean to interval and ratio data, but for median we can apply median to ordinal, interval and ratio data. Number 3, we cannot apply median to nominal data, not applicable to nominal data. Number 4, it's unaffected. Now I'm going to give you this classic illustration how exactly mean gets affected but median doesn't get affected because of the presence of outliers. Unaffected by outliers. So let me give you this illustration. This is the score of a class in math test. And as I told you, the population size is 100. Population is 100, but I'm getting a sample. The sample size is 17. So this is the score: 3, 4, 5, 7, 8, 9, 11, 14, 15, 16, 16, 17, 19, 19, 20, 21, 22. Now I have arranged this in an ordered manner, ordered fashion. Now what you need to do, you need to strike the first versus the last, the second versus the second last, and so on and so forth. So if you were to strike it and go on, finally you are left with 15. So that is the median. And in this case, the total sample size is 17, so we are able to do that. So having got that 15, now if I were to find the mean, let me get the mean of the population, sigma x divided by n. I'm going to add it over here. So 3 plus 4 plus 5 plus 7 . Okay, we're getting 225. So 225 divided by 17, right, total number. So this is approximately 13.2, provided of course I have summed it correct. Now having got that, x is equal to 13.2, the median is 15. Now imagine this 3 is replaced with 103. Okay, that means 100 is incremented. So let me, instead of saying 103, I will say 100. One person has got 100, right? So this is the class average, or I would say this is the mean for the sample. So on an average, students have scored 13.2. That is the conclusion that we are drawing here, right, in the math test. And the median is 15. That means if I were to infer this, this is nothing but on an average, students have got 15 marks in the math test. Now between the median and the mean, we got some correlation, or I would say there is not much of a difference between 13.2 and 15. So we can draw a better idea of the class. Okay. Now having mentioned that, suddenly there is an outlier. One student has got 100. Now I need to actually add 100 over here. So that would mean I need to take away 3. 3 is dropped and 100 is added. So 222 plus 100, right? So this is the new mean. So this is going to be 322 because I've already removed 3 and I've added 100 divided by 70. So let me check the mean. 322 divided by 70. So what do I get? This is what I get, 18.9. Now, do you think the median will change? No. No change in the median. No change in the median because of the way in which median is calculated. So that would mean median will remain 15. Now there is a huge difference between 15 and 18.9. Students, on an average, if students are getting 18.9 in the math test, that is totally different from getting 15 on the math test. Okay, so having given you that information, even if I were to change this 22 to 100, definitely there will be a change in the mean, but the median will remain the same. So that is the power of the median. It will not be affected by outliers. So having given you this information, let me head on to show you how to extract the value of the median in cases of grouped data. Okay, before I can show you how to obtain the mean for grouped data, or I would say median for grouped data, let me just show you the median when the sample size is even, right? So even number of numbers. So let me take this illustration. This is the sample I'm taking, sample size, and as usual, this is the score obtained by a class. So the population is equal to 100 students in the class, and this is the sample size. So I'm going to take it as 3, 4, 5, 7, 8, 9, 11, 14, 15, 16, 17, 19, 2 19s are there, 20 and 21. Now if you want to obtain the median, what you need to do, as I mentioned to you, I will strike this off, this off, this off, this off, this off, this off. That's the usual way we do it, right? That is applicable for odd number of entries. So in this case you got 16 entries. So if you were to continue like that, 19, 19, 17, 17, 9, 16, 11, 16, now you are ending up with 2 entries, 14 and 15. What you need to do, you take 14, add it with 15 and you divide by 2. So this is going to give me 29 divided by 2, which is going to be 14.5. Now this 14.5 is actually lying between the 8th and the 9th entry. Okay, the value is over here, and this is what the median for this sample. So median is equal to 14.5. Now if you were to replace, say 3 by 88, the mean will be affected. So if you were to take the mean, let me take the mean for this. The mean x bar is equal to sigma x divided by n. So that is going to be the sum of all these entries divided by number of entries. So I'll show you the value: 3 plus 4 plus 5 plus 7 plus 8 plus 9 plus 11 plus 14 plus 15 plus 16 plus 16 plus 17 plus 19 plus 19 plus 20 plus 21. So you are getting 204 divided by 16, and that is equal to 12.75. On an average, students have scored 12.75 marks in the math test. Now if I were to replace 3 by say 90, and in this case what happens, I take away 3 and I add 90, so that's going to be 193 or 2, right? So 204 minus 3, add 90, so you get 291 divided by 16, you get 18.1875. So this is the value that you're getting. Now the huge difference between 12.75 and 18.1875. Now if you were to see the median is very much closer to the mean, 12.75, but between 14.75 and 18.1875 there's a huge difference. So the median and the mean over here, new mean, they are leagues difference. I would say there's a large difference. That's the best way, right? But even though I place a 90, the median will not be affected. As I mentioned here, unaffected by outliers. Okay, so that is how you find the median of a sample which is even in number. So having given you that, now let me go on to show you how to find the median when you are encountering grouped data. Now this is very important, and for this you need to get this formula. So median is equal to L plus, the formula looks a little bit confusing, don't worry, I'll explain it to you, CFP divided by F MED. I'll explain to you what the MED stands for. So this entire thing has to be product multiplied with W, and let me name or let me explain these things. N is nothing but total frequency. Total frequencies. Now L is the lower limit of the median class. Lower limit of, I'm writing it as MC, median class. I'll explain to you when we see the question. CFP, cumulative frequency of the class preceding the median class, and W is the width of the median class, and FMED, I got one more thing, FMED is the frequency of the median class. Now this is quite a sum, and the best way to understand this is via an example. Okay, so this is the requirement. We are expected to find the median of the grouped data. And this is the data given. The following is the data of student performance in math test. So this is the class interval. This is the frequency, and we have been given the following. So between 20 to 30 we have got 6 students. Between 30 to 40 we have 18 students. Between 40 to 50 we have got 11 students. Between 50 to 60 we have got 11 students. Between 60 to 70 we have got 3 students, and 70 to 80 1 student has scored. So this is the frequency. Now to get the median for the group data, foremost what you need to do is you need to calculate the cumulative frequency. So you start with 6, add 6 with 18, you get 24, and then you add this 24 to 11, you get 35, add this 35 to 11, you get 46, add 46 to 3, you get 49, add 49 to 1, you get 50. So this is how it goes, right? Add it like this, then you get this, then you added this, then you get this, then you add this, then you get this, add this, you get this, add this, then you get this. So that's the way you calculate cumulative frequency. Now next what you need to do, you need to add up all these frequencies. So that will give you 50. Now what you need to do first and foremost, you need to find the median class. So for that, to get the median class, you divide 50 by 2, you get 25. Now go up to the cumulative frequency and look where exactly you can locate this value 25. Now this is 6, this is 24. Now 25 is located over here. It's not located here, it's located here, because 24 ends here and 25 will begin over here. So this is our median class. Now according to the formula, let me write the formula down. The median is L positive n divided by 2 negative C F P divided by F M E D, and this is multiplied with W. Now foremost, L is the lower limit of the median class. Lower limit of median class. So what is the median class? 40 to 50. And what is the lower limit here? 40 is the lower limit. So L is obtained to be as 40. Now we have already got N, which is 50. Now we need to know CFP. Now what is CFP? CFP is the cumulative frequency. Cumulative frequency of the class preceding, that's a very important word, preceding the median class. So which is the median class here? This is the median class. And what is the cumulative frequency preceding the median class? 24. So this is going to be 24. Place that. We've got L, we've got N, we've got CFP. W is the width. So between 40 to 50, what is the width? Between 20 to 30, what is the width? Between 30 to 40, what is the width? It's always 10. That's it. Write that down. So you got L, you got N, you got CFP, you got W, and FMED. What is FMED? That is the frequency of the median class. Frequency of the median class. So what is the frequency of the median class? The frequency of this is the median class. The frequency is 11. Now what you need to do, substitute all of these values. So L is 40, N is 50, CFP is 24, the width is 10. You divide by the frequency of the median class, 11. So use the calculator, evaluate all of this, and you get a value of 40.909. So this is the median of the grouped data. So this is a lovely question, and it is very important that you know how to find the median of the grouped data. Now next comes mode. I've already given the required lesson on mode, but in this class I will perform a brief review on mode, and I will also teach you how to get the mode of grouped data. So having mentioned that, let me give following characteristics of mode. Now what is mode? As I explained to you, mode is the most frequented value in the data set. Number 2, it can be applied to nominal data, ordinal data, interval data, and ratio data. So mode is applicable across the board. Now if the dataset has got two modes, we call it as bimodal, okay, or bimodal. If it has multiple mode values, we call it as multimodal. Now let me give you this illustration. Suppose you have the following scores, following sample is student scores in math. So you got 35, 41, 44, 45, 37, 41, 44, 46, 37, 43, 44, 46, right? So what is the mode here? How many modes this has got? It's the most frequented value, right? So in this case you got 44 occurring twice and 46 occurring twice. So two of these values are occurring twice. In fact, 44 is occurring 3 times. So 44 here, 44 here, 44 here, and then 46 here, 46 here. So of these values, which one do you think is the mode for this data set? So have you found out the answer? Now if you were to take account of the number of times 44 is occurring, 1, 2, 3, and number of times 46 is occurring, 1 and 2. So according to definition, mode is the most frequented value. So mode for this data set is 44, because it is the only value that is occurring more times, or the most number of times. That's the absolute way to say. Okay, so having given you this, let me head on to explain how to find the mode of the grouped data. So we got the student scores in math test, and that is given in the following fashion. So this is the class interval, and this is the frequency. So between 20 and 30 we got 6 students scoring this, between this range 20 to 30, and between 30 to 40 we got 18 students, between 40 to 50 we got 11 students, between 50 to 60 we got 11 students, 60 to 70 we got 3 students, and 70 to 80 we got 1 student. So frequency tells us the number of students who have scored the respective mark, and that respective mark is present in this class interval. So having given you that information, what we need to do is we need to find out the mode. Now to get the mode, what we have to do is we have to first write down the formula. So mode is equal to LMO positive D1 divided by D1 plus D2 times W. So this is the formula we will have to use. Now what is LMO? This is nothing but the lower limit of the model class, and D1 and D2, I will show you how to extract D1 and D2. So we need to first locate the model class. So for that, go to the frequency and locate the highest value that you can see here. So in this case 18 is the highest value, so that is going to be leading us to the model class, and find out the lower limit. So in this case LMO is equal to 30. Now to find D1, go to the frequency. Now from 18 you subtract the one frequency which is above, subtract 6, so you get 12. Now to get D2, from 18 you subtract the low frequency which is featuring below 18. In this case it's 11, so you get 7. So now what you need to do, of course W is going to be the width, right? So in this case W is equal to 10. So take all these values and substitute it in the formula. So I'm going to use this page, this part of the page. So L is 30 plus D1 is 12 plus D1 plus D2, 12 plus 7 times 10, right? Times 10, you evaluate this and you get a mode value of 36.31. So this for the grouped data. There's one more important thing that you need to know in the measures of central tendency, and that is going to be percentile. So I'm going to show you that. So this is the most important question. When do we use the mean, median and mode to understand the data? So that's very critical, right? Now I'm going to give you 3 illustrations. So illustration 1, imagine you have an exam and the question paper is very easy. So the x-axis represents the marks, y-axis represents the frequency. Now If I were to plot this, I'm going to take a left skewed graph. Now the sample size is, or the population is 100. You can take it as you want. Now if you were to plot it, you will have a graph which is left skewed. This is just a case scenario. Suppose you have a graph like this. Now 100 students are represented here, and this is the marks. So imagine if I were to have 0 here, 10, 20, 30, 40 and so on and so forth. You can clearly see that as we move up 40, 50, 60, more number of students got good marks because the question paper is easy. But there is a few number of students who are outliers in this case. They have just got 10, 20. It happens, right? Even though you give a very easy question paper, there will always be a group of students who are not doing the exam well. So this is the graph that represents them. But there is a major frequency, there's a major chunk which has really done well. So anything above 50 is considered good, right? So that frequency is hitting over here. It is hitting a very high number here. Now the question comes here is, what is going to be the mean, the median and the mode? Now if you were to locate the mean would be lying somewhere over here. The median would be lying somewhere over here, and this is going to be the mode. So this is going to give me the mean, this is going to give me the median, and this is going to be giving me the mode. Now on the other end, if the question paper is difficult, and if you were to make the plot, you will have a graph something like this. This is right skewed. This is frequency and this is marks. So only a few number of students have got really high. So this would be the mode. This is going to be the mode, and this is going to be the median, and this is going to give me the mean, because many students have not done well. So having given you that information, a critical observation here is, no matter whether it's left skewed or right skewed, the median is always the central value. Have that in mind. This is the central value. The median is always lying in the center. Now if the data is normally distributed, so that means you have a normal distribution curve, you can use the mean, the median or the mode to represent or to understand the data or to describe the data. It doesn't matter if you are getting a bell-shaped curve, but whenever you're getting the curves to be like this, you have to go to the median to get a firmer understanding of the data. So that is the knowledge point I wish to give you here. I will move on to explain percentile. Now we have come to the conclusion of measures of central tendency, and in this topic we will learn about percentiles. Now you might be wondering, what is this? It's sounding more like percentage. And what is the difference between percentile and percentage? Now percentage is an absolute term. This is an absolute term, and this is a relative term. Now what is the meaning between absolute and relative? Now you have a question paper in math, and if a student says the student has got 90% score in math, it means the student is unable to answer 10% of the paper. So this is a good score. So 90% of the questions asked in the paper to the student is known, and the student has scored a good absolute value of 90. And of course, having mentioned that, 10% of the paper is not known to the student. So that is the understanding when you say percentage. But if a student says this is a score 90 percentile, then it does not mean the student knows 90% of the paper. It only means that 90% of the test takers have not done well, or I would use the term 90 test takers are below and 10% lie above. Having given you that, let me extend this. What is the meaning of percentile? It is the measure of central tendency that divides a group of data into 100 parts. This is a very important point. Number 2, the median and the 50th percentile have the same value. And number 3, it can be applied to ordinal, interval and ratio data, but you cannot apply it to nominal data, not applicable to nominal data. So having given you all this, let me do some questions. Now let me give you the steps that you need to take to calculate the percentile. First and foremost thing, you organize. It's a very important term in statistics. Organize the data in ascending order. Ascending order means in increasing order. Next, you have to, or you want to calculate the location of the percentile. Now, why do we need this? I'll give you that example so you'll have a better understanding. So that is given by a formula. I is equal to P divided by 100 times N. This is the number of data points. And this will give us the location of where exactly this percentile is located. Now there are three, I would say 2 important things that you will have to know. Now, if you get I to be a whole number, then you will have to take the average of values that are at ith position and I plus 1th position. Okay, now if I is not a whole number, then the percentile is at the I plus 1th position. Then we just take the percentile is located at I plus 1th position in the ordered array. So having given you that, let me go up and give an illustration. Okay, this is the score of students in a competitive exam, competitive test score, and we've been given 14, 12, 19, 23, 5, 13, 28, 17. So for what we need to do is we need to arrange them in ascending order. So what is the smallest score? 5, next comes 12, 13, 14, 17, 19, 23 and 28. So what is the formula? I is equal to P over 100 times n. 1, 2, 3, 4, 5, 6, 7, 8. Right? Now, say for example, your cousin comes up to you and she tells you that she has given this competitive test and she has scored 30 percentile. Now you want to know what exactly that this 30 percentile corresponds to the scores that have been displayed here. Now 30 percentile is not 30 percentage. This is not equal to 30 percentage. That is why we got this formula. I am going to put 30 there, divide by 100 times 8, cancel the zeros, you get 4 divided by 10, which is equal to 2.4. So this is the position index. I is equal to 2.4. Now clearly you can see that I is not a whole number, so the percentage is located at I plus 1th position. So the location of the percentile is I plus 1th position, and in this case 2.4 plus 1 is equal to 3.4 position. Now what is 3.4th position? Go over here, count 1, 2, 3, 3.4. You can't go into 3.4, so you rest at 13 or rest at 3. Now what score you get? 13. And your cousin has got a score of 13 marks. That's it. So 30th percentile over here corresponds to 13. Now imagine, as I mentioned to you, someone were to tell you 90 percentile. It doesn't mean the person has got 90 percentage. So that completes our study on measure of central tendency, and along with that we have studied a lot of important topics like mean, median, mode and percentile. So we will again meet in our next class where we will be studying on this portion. So like, share and subscribe to our channel. Until we meet again, thank you everybody.